So we should have made the code to start our targeting function, and these were the steps to complete that. Hopefully you were able to test this. What happens if I type in 7 into my height? The light goes off, right? Because we're trying to figure out if you're greater than 7, and 7 is not greater than 7. If we wanted it to be 7 and higher turns the light on, then we would have used greater than or equal to, a different function. Terrific. So one of the things that we explored or found out during this exercise was that some people ended up in a point where they got a broken run arrow. See, this run arrow is white? If there is anything that's hooked up incorrectly, like let's say I put two wires, a wire carrying a number and a wire carrying a Boolean together, and I connect them. You can't do it. It's like putting two different voltages on one wire. What happens? Well, mathematically it's not one voltage or the other voltage, it's some new voltage, right? And it's really, what I just did is more like hooking an electric wire to a water pipe, right? What does that do? Who knows, right? It makes you electrified water. Who knows? So that's not compilable. So when you have a compiling error, you get a broken run arrow. When the run arrow is broken, you can click on the run arrow, and it will tell you what's wrong with your code. Now, guess what? It's telling you in words, so you have to read it. Okay? It's not just it's not like Clippy, and it doesn't point to the thing. Clippy's the Microsoft help thing. Okay, great. So you can double-click on either of these problems, and it takes you right to where the problem is in the code, and it gives you a suggestion on how to solve it. Notice also, if you float over the top of a broken wire, it tells you this wire connects more than one data source. Well, think about that for a second. There's a data source on this wire that 7's getting put onto the wire, and that wire is now connected through here. There's another data source that's connected to the same wire. So there are two data sources for that wire. We can only have one. We disconnect that, and now the run arrow is white. So when you run into a situation like you had back there where you have a broken run arrow, you click on that broken run arrow, you read what's wrong with your code, and you read the solution suggestions and you try to implement them. Does that make sense to everybody? Great. So let's come back to reality. So to test this, you know, I said is 5 too high? Well, I run this and it turns off. Where else am I going to test? If 7 is my change point, I want to test above 7, so let's try 9. And then, of course, I want to test somewhere in the middle. So there's my 7. What if I put in 7.1? What do we predict? It's going to be too high. Great. So, and what if I put in 6.9? If I really want to get, you know, tricky, and I could keep doing that, but I now trust that this works. But notice that I had to click like 700 times to do that, you know. And if I wanted to keep changing this, I have to keep running and keep changing, and that's a drag. So one of the things that you might want to do to some code to make it a little more interactive is to make it run until a condition is met. And you can do that with a structure. So we learned about functions, we learned about constants. Now we're going to add a new vocabulary item in. This is a structure. So if I come back to the presentation, what we're going to do is we're going to make a VI that runs, keeps the program running until a stop button is pressed. Now let's think about that for a second. So that means I need to add something to the front panel. What do I need to add to the front panel to fulfill that? I'm going to keep the program running until a stop button is pressed. What do I need to add to the front panel? A stop button. Great. Let's add a stop button to the front panel. Don't do this with me, but watch while I'm doing it and then do it afterwards. So I put my stop button down. There's my stop button. Great. I right-clicked. Stop buttons are on or off. So I found it under the Boolean section, and there's a thing that's actually called a stop button. So we like that. If I'm looking for a stop button and something's called stop button, I probably should use that. Okay? Great. On the block diagram now, I have to add something that defines a space that's going to happen over and over and over again, and a space that is not going to happen over and over and over again. A structure has an interior space and an exterior space. So to drop a structure is a little different than dropping a function. When we dropped the function, we right-clicked, we found the function, we clicked to pick it up, and we clicked to drop it. Great. By the way, this is a good time to explain Control-Z is a great way to undo things that you've just done. To drop a structure, you go to the Structures palette. Notice that there's a thing called a while loop. A while loop happens until a condition is met, and we know that because if we use Control-H and we read, it says that. Okay? I'm going to drop a while loop by clicking to pick it up. Click. Now it's on my cursor, and I can define the area by clicking and dragging a square on the block diagram. This now defines the area that's going to happen over and over and over again inside, and then outside is going to happen how many times? Once. Everything inside of the structure is affected by the structure. Everything outside the structure is not affected by the structure. So inside the structure is repeating. Outside the structure happens once. Okay? Great. We just wanted everything to happen over and over again, so we want everything inside the while loop. Let's see that one more time. Right-click, find the structure that we want. It's on the hand. Go to the top corner of the area that we want to have affected by the structure and drag the area. There are 3 parts to a while loop that came in. One is the border, right? There's the border of the while loop. That's the actual while loop itself. If you right-click on the border, you find out things that you can do to the while loop, okay? There's another thing down here that's got a green border. Where have we seen green things before? Booleans, right? Trues or falses. So a while loop is going to happen until a condition is met. That condition is either met or not met. And so this is the conditional terminal. It's green and it accepts Booleans. This over here is a blue thing. We've actually seen blue before. I didn't really talk about it, but a blue is an integer. 7 is an integer. So this I, what do you think this little blue I does? If I float over the top of it, it says loop iteration. It tells you how many times the loop is iterated or how many times it's run. We're not going to use that right now, but if I go to run the program, oh man, run bear is broken. What's wrong? What do I do? I click it. It says your while loop conditional terminal is not wired. What's the while loop conditional terminal? Oh, it's this thing. And if I didn't know that, I could hit Control-H, and this detailed help would tell me what the conditional terminal is. Right down here. Conditional terminal. 3. 3. So there's no manual with LabVIEW. It's all built in. So any question that you have can be answered by using the help or the context help. So let's hook that up. What should happen to the run arrow? Boom. It goes white, which means now this is compilable. And we hit the run button, and now we can change this on the fly. So now this is running. How do I know it's running? The run arrow is black. And I can hit the abort button. I don't want to hit the abort button because I've also got a much better way to shut down, which is to hit the stop button. And now we've made a while loop. So go ahead and add a while loop to your program so that you can keep the program running until a stop button is pressed, and then I'll have instructions when we come back.